Hi, everyone. Well, I guess technically, welcome back from spring break. I hope you had a nice time. So today, you're going to watch this video. I'm going to review the quiz that we were going to take today, and then I'm going to do a little bit of review and tell you what you can look forward to coming up on the test, which will be next class. So I've got the quiz here, and we're just going to go through it. And it's been a long time since I've done this on Zoom, so we'll see if I remember how to do this. All right, so question number one, what are the units of the specific rate constant for a reaction that is overall first order? So if I have a reaction that's first order, I'm going to have an equation that looks like rate is equal to K. Let's just say A, okay? Now, we're trying to solve for the units for K. So rate is always going to be a change in concentration, which is moles per liter by time. And in this case, the time I'm given is seconds, is equal to K times the concentration of A, which would end up being moles per liter. To get K by itself, I'm going to multiply both sides by liters over moles. The liters cancel, the moles cancel, and you're left with A 1 over seconds. Okay, so that's what that's going to be. Question number two is a little bit of stoichiometry. So we have an equation here, A plus 2B gives me 3C. Now, if the rate of disappearance of B is 0.15 molar per minute, what is the rate of appearance of C? So we're literally just going to be like, okay, so if B is 0.150 for B, I know it's going to be in a 2 to 3 relationship for B to C. Okay. So then we have to do some math. Okay, I can do this math. 15 times 3 is 0.450 divided by 2. Half of 40 is 20, 0.225. The answer is going to be C. Okay, so again, we're just looking at our ratio. Okay, so if it disappears for B, what is the rate of C? Again, just based off of my balanced equation. Question number three, which of the following statements are true regarding chemical kinetics? So the rate of the reaction is expressed in concentrations per unit of time. Okay, that is what rate is, change in concentration over time. Effective collisions must occur in order to break bonds of the reactants. That is correct. So not only do we have to collide, we have to have what is referred to as effective collisions. We have to have them hit with the right amount of energy and in the right orientation. And the rate of the reaction is only determined by the appearance of products. No, it also has to do with your reactants as well. So the answer is going to be C, 1 and 2. Which of the following factors affect the rate of the chemical reaction except molar mass? Molar mass was not one of them. This is the answer. Concentration does. The surface of the reactants does. Remember, the smaller it is, the faster it will react. The temperature does. If I heat it up, I'm going to make those things move faster, and therefore the reaction rate will be higher. Okay, so we'll go down to the last couple ones here. Given the following equation, okay, we've got this. Which of the following statements are true? The M represents the order with respect to A. That is correct. The brackets B represents the molarity. That is correct. Remember, brackets mean molarity. The subscript O represents the order. That's not true. That actually represents that it is the initial concentration. So it's basically the concentration at time 0, so the initial. K is the rate constant. That is true. So it's 1, 2, and 4, which is D. Okay, for questions 6 through 8, you can use your choice once, more than once, or not at all. Which one is going to be a second order reaction? That's going to be B. Okay, straightforward. Represents a reaction that is 0 order. That's going to be C. The rate is just the rate constant. I have no concentration or whatever. represents a reaction that is third order overall. That's going to be E, and let me tell you how. So if a reaction's third order, I'm going to have rate is equal to K. Let's just use A and B, and one of these things is going to be squared. So this is going to be for my K value. So rate is going to be moles per liters times, we'll just use seconds here, is equal to K. Moles over liters. This is going to be moles squared over liters squared, which gives me moles cubed over liters cubed times K is equal to moles over liters times seconds. Multiply both sides by liters cubed over moles cubed. The liter goes away on the bottom, this 3 becomes a 2. That mole goes away on the top, this 3 becomes a 2. That's how it's, and so if I have molarity to the -2, that is liters squared over moles squared, which is what I have. And then of course, times seconds. Okay, so that's inverse molar squared, inverse seconds. So remember, when you inverse it, when you raise it to a negative exponent, you just flip it. What's on the top is on the bottom. All right, and these questions here give you a good idea of what kind of questions you're going to see on the multiple choice. Questions like this, you'll be given data tables full of information like the free response questions, and then have to determine the rate order or things like that. You might have to find the K, which we're going to see here in the next question. But these are, I mean, there's only so many kinds of questions you can be asked about with kinetics. So let's clear this and go to the free response question. Okay, as promised, you get another data table full of information. You have to determine the rate law and calculate K and determine the overall rate order. Okay, so remember, if I want to find the rate order of A, I need to look at 2 trials where B remains the same. So that's 1 and 2. So, okay, so from trials 1 to 2, the concentration doubles, the rate doubles. That makes A first order. I'm going to figure out the orders, and then I'm going to write out the answers. Now, to determine B, we look at 2 trials of A that remains the same. That is 2 and 3. Well, that's times 2. That's times 4. So that means it's second order. So my explanation. Okay, let's see if I can fit this in here. So for A, in experiments 1 and 2, I'm going to write it over here. The concentration of B remains the same. The concentration of A doubles while the rate doubles, making it, what is that, first order with respect to A. Okay, so you see here, question 3 is worth, or question A is worth 3 points. 1 point for each explanation, 1 for my rate law, which will look like this. We said A was first order, B is second order, so I square it. Okay, so my other explanation. In experiments, we did 2 and 3. The concentration of A remains the same. The concentration of B doubles while the rate quadruples. Making it second order with respect to B. Okay, so those are my justifications, my answer, my explanations, and that is my rate law. Now, I'm just going to erase this stuff that's on here so we can see this better. Now, what we want to do for the next part is calculate the K with my unit. Okay, so I'm just going to plug in the information from experiment 1 into my expression, and it's going to be 0. What's happening here? Draw. 0.50 times 10 to the negative second. This is moles per liters times hours is equal to K times 0.10 moles per liter times 0.20 moles per liter. I have to square that. Please don't miss that part. Okay, that's squared because B was squared in my rate law. Okay, I'm not going to do the math for you. You should know how to do this math. The number 1.25 and the units, you can do liters squared over moles squared times hours. So you should be doing this problem too, making sure that you get that answer as well and get those units. This question is worth 3 points, 1 for your work, 1 point for the numerical answer, 1 point for the units. And then the overall order, you just add up the individual rate orders and it is third order overall. Okay. Now on the test, for the kinetics portion, it's going to be a question just like this. I'm going to give you a data table. You have to determine the rate orders for each individual thing, then write your overall rate order, calculate K, and then there's going to be a mystery one, just like we did in the notes. You have to determine what that's going to be. Okay. Very straightforward. No real tricks with this. It's all done the same way each time. Okay. So like I told you in class, please, if you have any questions, feel free to reach out. Watch the old video on the kinetics notes if you have questions. Okay. So let me do this and clear this and let's see. Now let's talk about a couple of things in your homework packet, and then I'm just going to go through and tell you the important things in on the test that you should do. Now, there are no real tricks, no real I gotcha kinds of questions. So first off, if you have not worked in your homework packet from the beginning, you should do a couple of questions each, okay? One very good assignment for the thermo portion of this unit is this one, thermodynamics differentiating data. It goes through all of the different ways that you can calculate enthalpy. It goes through, oh, that's a dog, someone's home. It goes through all of the different things that we did, bond energy, entropy. It goes through Gibbs free energy. Make sure you work through those. Remember, for our thermo unit, we did only a few equations. Let me write those down for you. We did Q equals MC delta T. We did Q equals N delta H of the phase change. We use this equation in our calorimetry. Remember, with calorimetry, we always do the Q of the water first. Whatever the water does, the thing inside of the water does the same number, just the opposite sign. And then you go from there and continue to solve for whatever it is that you need. I mean, the first quiz that we did, the heating curve one, is going to be a good one. I'm going to leave that for the sub to pass back to you. So you should look over that. And if you got the questions wrong, I would go over them. But really, everything there is in the notes. Like I said before, if you need to go through and look at the old videos, please do that. But again, what you should be working on after you watch this, okay, you should work on this thermodynamics differentiating data assignment. You should already have done 2 out of these 3. And remember, this third one I said has to be calculated mathematically. You can look at the answer key to see if you can figure it out. The one on the test will not have to be done like that. And then, of course, we've got the study guide. The study guide is going to give you a little bit of each of the things that you need to look at. Now, let me stop sharing this and let me just look through. Oh, it's dark now. Let me just look through the test and just give you some quick things that you need to look at and make sure you understand. Okay, so I already went over the kinetic stuff. That's pretty straightforward. For your thermochemistry, thermodynamics portion of it, make sure you understand those different enthalpies that we talked about. Enthalpy of formation, enthalpy of fusion, enthalpy of vaporization, enthalpy of neutralization, enthalpy of combustion. Okay, I'm going to give you different equations and different things to look at, and you'll have to identify which one's which. Let's see what else. We've got delta G calculations. The definition of entropy. Is this thing increasing or decreasing entropy? What's happening with a calorimeter? A calorimetry question. So really the multiple choice isn't anything crazy. Remember, for the multiple choice questions where you are doing calculations, make sure that you, oh, there I am. Make sure that you make the numbers work for you. Again, we know how that works. For the free response portion of the test, that's going to be the thermal portion. There is a Hess's law question. I'm giving you a series of equations. You need to manipulate them to make it look like the final equation. I've got a question about enthalpy of combustion. I've got a question about entropy. And then I have a calorimetry question. Okay, not even a bomb calorimeter. Nope, that is a bomb calorimeter question. So make sure you know how to do that. We did it in the notes. We did it on the first quiz that we took. Okay, so if you have any questions, please send me an email. I'll be near my phone, obviously, that I can respond if it's something easy. If it's something like super crazy and you like really don't know what to do, I mean, we can talk about maybe doing something on Zoom, but yeah, just let me know if you have any questions. Like I said, we will be taking our test next time. Okay, so, okay, bye.